Okay, just a brief introduction on my side before I will hand over the word and all the content to no, let's see, something's happening. To Professor Ferreira as our speaker today. But for those who hasn't participated in these STAR talks, they are quite a new format, but we have had a couple of we had about the thematic groups, and we have had now on one prior. So will be the second one in the series of webinars that we at STARS EU Alliance refer to as the STAR talks. And the STAR talks are an open webinar when we share knowledge about what we are doing within the network and in collaboration with partners. It's trying to be an open webinar, so it's open for everybody to attend, and it should be cross-sectional, multidisciplinary talks about interesting topics that addresses some of the challenges that we see within the Alliance and what we are trying to do within this STARS EU Alliance. And those who are not that familiar with the STARS EU Alliance, it's an alliance of 9 universities around Europe, Spain, Portugal, France, the Netherlands, Germany, Sweden, Poland, Czech Republic, Albania. And we are addressing those future challenges that we see when it comes to the sustainable development, when you see the transition of demographics. We see all those kind of future seen priorities made up by the UN and by the European Union of future challenges, not least when it comes to the green transition and the circular economy that we need to develop for the future. And this talk today, presented by Dr. María Jose Ferreira, will have, as you see on the screen, the theme of Portuguese footwear cluster, innovative green materials, processes, and products. Dr. María Jose Ferreira has a degree in chemistry, master in environmental sciences, and a PhD in environmental engineering. And she works with the CTCP in Portugal on footwear, and has an experience on projects and physical and chemical testing of footwear and related materials, and safety and work of environmental manager. This is done in collaboration with the thematic interest group that IPB in Bragança is the lead of, which is named Circular Economy. So before I hand over the word and the presentation to Dr. Ferreira, just that everybody's aware of that this webinar is recorded and it will be displayed later on the website of this alliance. And if you not accept that, you will need to leave the meeting, because it's you could be seen on screen and that your name or your face will appear if you have questions, if you have any interaction whatsoever during the webinar. But I hope that you're all fine with that. And Professor Ferreira, Dr. Ferreira, please, you will have up to 45 minutes of information presentation. Then in the end, that there will be questions. If anybody has questions, please leave them to afterwards, and then we will have a discussion with questions during this hour of webinar. So please welcome Dr. Ferreira. The floor and the microphone is yours, please.
Thank you so much. Good morning. I would like to begin by thanking the Star Alliance and also you, Professor Gunnar Bertensson, and also Professora Filomena Barreiro from IPB for inviting me. It's for me both a pleasure and an honor to be here. I'd like also to thank all the participants and to congratulate you for this perfect timing and organization. As you mentioned, I'm talking about innovative materials, process and products deployed in Portugal in partnership with many institutes, as you will see. We will begin by a small context and then present main results of GreenShoes4.0 project, and also I will introduce you to a new project that is going on that is named BioShoes4All. Beginning by this small context, just to give you some figures about our cluster. Portugal, we produce, of course, footwear and leather goods, but also materials, components, technologies that are needed to produce footwear and these leather goods and so on. It's a very relevant activity in Portugal, employing over 40,000 persons and has an economic trade balance that is very positive. In this slide, you see the rate of growth of our sports, and over the last more than 10 years, they grew 55%. Portugal exports over 95% of what produces, and actually we are the second European footwear producer. Also, we have been producing and exporting for over, I have here 175, that is more, countries now in 23. And one of the issues regarding footwear made in Portugal is the knowledge of its quality, of its differentiation, and this gives us the second highest average export price in the world, and is seen here. So it's really a trademark for differentiation and quality. CTCP, we are the Footwear Research and Technological Center. We have over near 40 years experience. We have more than 65 persons, and we can see more about us in the website. These are our main areas of intervention. You already mentioned the research, not only in terms of materials, but also digital technologies. We have a big involvement in quality control for the footwear that is produced and exported, and also we can do tests for other countries in Europe. Training and qualification are a must, are areas of big work also. I am responsible for research and sustainability, and would be glad to collaborate with all of you in the future, and if you have needs or materials that somehow can interest in footwear. Also, I'm the head of the quality control. Again, we are at your disposal in these areas. Now, moving to the real part of the presentation, GreenShoes4.0 project, that was really about to produce new products, materials and technologies for the sustainable footwear and leather goods. We organized the presentation in 3 areas. First, we will talk about the products, then the materials and technologies. It's just a summary of what was done by the 23 partners, 8 of which were research, and IPV was one of our research partners too. Here you have information regarding the companies that are now putting in the market the results produced. So this project ended in June 23. Regarding the products, a lot of studies were done and tools developed to produce develop new concepts of products and products that are now largely been implemented in the European and American market. That these are the main markets of footwear sports that actually, even though we are trying to increase the regional area of intervention of our products. One of the main topics and one important tool developed was to really address eco-design from the point of view of footwear, investing a lot in defining durability, repairability, and reuse approaches, and also studying ecotoxicity and not standardized technologies, not really yet available ISO standards or AN standards in some cases. So studying ecotoxicity tools, new ones, and testing the biodegradability and compostability also. Life cycle analysis was the basis, was the support to, let's say, tune all the developments in the product. In this case, we use the product environment footprint methodology that is being developed at European level for footwear. This is an area that we are following. In fact, we were coordinating the Life GreenShoes4All project, in which this methodology was first tested in a European Life project. Applying this technology, this methodology, we estimate the environmental impact of 16 impact categories that are here presented. Of course, that climate change is the one that normally we communicate, but all these other categories are studied and allow us to identify the areas in which the footwear or leather goods or components have more impact, and tune these hotspots to decrease globally the environmental impact of the products or materials or whatever. In complement with all these environment assets, we studied the products and tuned the products from the point of view of comfort, doing biomechanical tests with persons and also with specific equipments that we developed in past projects and that are available at the Institute, like walking simulators, sensors to measure the temperature and humidity inside footwear while in use. All this testing allows us to develop new constructions, new concepts of footwear, like the one that, for example, that you see in the image, with adequate impact, meaning shock absorption, good resilience, so energy return, climate comfort. Here you see some examples of the products developed. I will present two types of products. In this case, you see materials that are leather, either the footwear and the leather goods are made in leather, mainly in leather. We studied and developed sustainable, more comfortable casual shoes, also luxury and even work footwear. All these have been supported by the product and footprint approach to reduce their impact on our environment. And in some cases, we were able to reduce, comparing to similar products, up to 30% their impact. Of course, they involve also the use of the materials that I will present in the next step of the presentation. One important aspect here, apart from the comfort and so on, is the durability. So we are betting a lot on having a high quality, durable product that you can like and use forever. Also, you see that designs are intemporal. In another dimension, and because we want to be as inclusive as possible, we also have here an example of products made with alternative materials, not incorporate leather. These are kind of also even certified as vegan products. In this case, one important work was to introduce in this type of products up to 100% of material that is pre-consumer waste, so recycling pre-consumer waste up to 100, and also a new concept for this kind of products was deployed, that is the closed loop. In this case, products can be sent to the brand using digital tools at their website, and in addition to have a small discount, the clients have the confidence that the products returned are grinded and the new compost prepared and can be fully recycled after post-consumption. So this was an important area. Of course, we did some other trials with post-consumption, but here I should say that while in the terms of recycling pre-consumer waste, we are giving firm steps and already in a good position. Regarding post-consumer products, they are quite complex. You see here, very simple product, but normally they are quite complex, and a lot of work and research is still needed to recycle post-consumer footwear. So it's an area of actual research, and I think future research in the near years. So this is an area that we would like to share with you and involve additional partners if possible. Another work was regarding the development and deployment of a very simple tool to begin working with traceability. This is mainly a tool to show the consumer what are the compositions and origins of the materials, of the main materials. In these pictures, you see that the materials identified are the out part of the shoe, the linings, and the soles. This is also a work that we begin and is continued at the national, and we hope also at a level of European projects that we are trying to participate. Now, regarding the materials, footwear in Portugal and leather goods, we are experts, and when I say we are the second producer in Europe, is of products made in leather. So, of course, that a lot of research is being done and was done in green shoes in this area. I would like to highlight the possibility that was studied with very good results of valorizing the leather waste themselves. So when we use leather, we are valorizing skins from the production of meat for human consumption. And only these kind of skins are valorized by our industry to produce leather. So it's already recycling of a sub-product or byproduct. In this case, during the production of leather, we all know that some wastes are produced along with also liquid fluids and so on. In this project, we focus a lot in the valorization of the wastes produced during the leather manufacturing, and were able to hydrolyze and prepare new chemicals that are used as retanning agents and also filling agents of the leathers. This was work that involved several institutes, including EPB and CTCP, STIC, and several companies, and these solutions are already being marketed. Here you see examples of leathers. Apart from this kind of work of cycling the leather wastes, we developed new formulations of leathers without chromium at all, and also new formulations of, and these are the wet white tanning, and new formulations of wet blue, meaning with chromium, in which the chromium 6, that is some problem sometimes, is really stabilized, the chromium stabilizer, and the formation of chromium 6 highly hexavalent chromium, highly minimized. Here another important aspect was to have approaches to obtain lighter leathers. One of the aspects that sometimes consumers complain is that the products are heavier, have more weight than comparing with other materials. And in this case, we were able, working with enzymes and some microcharges, to develop new, lighter, very functional leathers that are also with higher cohesiveness, and this means that they have higher area, surface area that can be used, so making the footwear production more sustainable. Naturally, a lot of work was also done to develop new materials and so footwear. In this case, we bet in rubbers because they are very durable, and also in thermoplastic materials that can be easily recyclable. The idea here was always to have lightweight products, lightweight materials that are as much as possible recyclable, in the case of thermoplastics, fully recyclable, and that even they are recycled materials, they have high performance. I should say that we, in the case of thermoplastic products, in some cases, we are able to have recycled materials with up to 95% of recycled material that have qualities similar, or in some cases even a little better than the virgin materials. This was done by studying formulations and compositions that involve the use of new additives like sealants and other materials that really promote the compatibilization of the polymers and give results that are very interesting. Again, here the thermoplastics are already being used, and the market is really very interested in these high quality recycled materials. Those materials were using pre-consumption waste, and here we also developing products that incorporate pre-consumer and post-consumer waste. Normally, we are using these wastes, and waste can be polymers, but can also be textiles, can be leather. We are introducing them after detailed pretreatment in new composites. The composites are aggregated by several binders or rubber itself. This is work ongoing. All these developments of materials and components and the identification of chemicals was supported by toxicity and ecotoxicity tests. Tests included plant tests, the soil characterization, and also some tests with human cells, selected human cells, and aquatic organisms. Moving to the technology, this is an important area. In this case, we focus in the different aspects. One was to create a model to connect the leather and the footwear. This is an image of how a digitalized leather looks like. Normally, when the material arrives to the footwear companies or leather goods companies, is necessary to digitalize the material and to define the areas of tension and the defects, and this takes some time. And only after that is possible to begin the nexting, so locating the pieces of the upper of the leather of the shoes or the pieces of the leather goods to be cutted, and after that the pieces are cutted normally using automatic machines. So in order to enable a faster and more agile production, what was developed was tools to digitalize the leathers at the leather manufacturing and identifying their defects and sending the images of the leathers ready to be nested, so the plan planning of how the leathers will be cut is done even before the materials arriving, and this allows to cut the cutting time and the production time in several days. This was done and is available at industrial scale now. Another area of work was not to develop injection machines. When the footwear gluing of the sole to the upper is an established process. Also, the injection molding of soles to an upper part of shoe is also a process that is established, even though daily we are doing new developments, new machines are appearing in the market. But here in the project, the idea was to develop simulation tools that allow us to plan, to make a good planning of the production. Planning in advance and also better using of the molds, and also establishing how the footwear and the sole components can use less materials, reduce the waste, reduce the energy, so valorize what we have, and not only in terms of times of machine and so on, but also the resources that are being wasted are decreasing. The footwear industry in Portugal, and I think maybe all around, normally has for the last 30 years invest a lot in developing technologies and process to make it more agile, to make it fast, just in time. Very many robotization and automations are already on, even though some are needed yet. But in the case of leather goods, meaning bags and so, many processes are still very manual. So this was one of the first projects, in fact in Portugal was the first project that we had with a specific area dedicated to develop new technologies to produce leather goods. In this case, monitoring and controlling the production using RFID technologies, using 3D printing to produce the molds and prototypes, developing new systems that allow the use of aqueous adhesives and paints, eliminating totally the using of, let's say, adhesives or paints with volatile organic compounds, and also drying systems that are energy efficient. So these results were very interesting, and also, again, really already in use in the company that was the, let's say, the receptor, the pilot tester of this. The company developed also a leather goods concept, and here you see one of the bag, and there is brand leather goods that valorize materials from previous production. So now almost, not completely, but almost 100% of the materials that are acquired are used in the products, either using as in the whole products that you see here, or small parts. They try to really have no waste. Almost they also already achieved this. Different area was also the study of numerical modeling and additive manufacturing here at the prototype level with the university. And finally, also work was done with very good, interesting results to promote online shoe sales with artificial intelligence, looking for what really the consumers want, trying to anticipate the needs of the market, and deploying and giving the consumer these needs. Additionally, it was possible to develop new tools to make the research. If you want to research a product, you can upload one small picture, and the tool makes search for you of similar products based on that picture. And also automatic segmentation. This is more a support tool to help the footwear manufacturers to upload interesting photos in their websites. Normally you have to take the supported by EU Next Generation is a project in the area of bioeconomy, sustainable economy. We are 30 partners. I have the honor of coordinating this project, also involving IPB, but many other institutes. In total, we are 20 institutes and 50 companies. The companies cover the whole value chain for the footwear. Of course, 12 are footwear manufacturer and leather goods. This is not by purpose, but 12 are also leather manufacturers and chemicals for leather, 12 for soles, materials, development materials, and also other chemicals that are needed. And we have also software, equipment, and so on, and companies from the retail business. The objectives of the project are to promote the transition of our cluster as a whole to the bioeconomy and to the sustainable circular economy, deploying products that are functional and circular and have a smaller footprint. We have developed new materials, new components, and in this project there is a lot of bet on the circularity too. In addition to be a research project, it's an integrated project that joins the preparation of training content and doing some capacitation. So by this moment, we are already 1 year and a half going on. We are in parallel with work of research and developing, transferring to the industry, transferring to the persons already what is being developing. Additionally, is a project that foresees the implementation at pilot level and investments at this pilot level of solutions that are needed to upscale the results of research. And of course, involves the dissemination, the broad dissemination of all the research openly, and seeks also the involvement of consumer of all ages. I should say that one of the areas that has been very interesting is we are having a specific program with the schools for children from the primary schools. Now we are also going to higher schools, so trying really to promote the responsible consumption within the population. The project is organized in 5 pillars, one regarding biomaterials, the other ecological and leather goods, footwear, circular economy, production, the technologies, and of course the capacitation and promotion. It will run till the end of 25, but some results are already coming. New leathers, for example, and products made with them. In this case, I would like to stress, for example, the use of wastes from pine trees, pine's bark, that is a problematic waste in Portugal and in some other countries in Europe. When it's not used, is staying in the fields, is staying in the forest, and sometimes is feeding fires. In this case, we are utilizing this pine bark to make tanning agents for the leathers with good results. Also, we are using fats that have no longer utilization in the human or animal food to make constituents, to make ingredients for these leathers. So would like to focus that above 20 agro-food or agro-industrial wastes have been identified, and many of them are already being tested in products. For example, an alternative material to leather that is made is, let's say, a textile that is coated with polyurethane in this case, and we were able to develop materials with bio content above 30%. Here in the slide I still have the 65 to 72, but now we can confirm over 72%, I will say over 70% of bio content. In this case, the substrate is a textile that is cotton, and the coating is a bio-based polyurethane. Polyol is highly bio, and some additional charges are added, like chestnut or olive wastes that have no use in animal or human food again, and allow us to have very distinguished really biomaterials. This bio content was established using C4 datation, C14 datation. Also a bet in materials that are alternative to leather again and have a high concentration of recycled material, so the support is has recycled wastes, and the top coatings using polyurethane include also wastes. So in this case, above 50% of waste of recycled material in the new recycled materials for the uppers. These materials are for uppers and linings and can be used either in footwear and in leather goods. Also, I would like to stress the development of BioTPUs, new BioTPUs for adhesive coatings and soles. And in this case, of course, we are involved, but also IPB is leading this area with Professor Filomena in charge of all the BioTPU areas in the project. I would like to also stress the launch of new materials for the uppers, complemented by materials for the soles, very light sole materials. The first machines for having physical expanded materials in Europe was deployed by this project, and is the E-Blast technology. Now, in fact, we have already a second kind of complementary tool being deployed. Instead of having physical expansion till the moment, normally when you want to have a polyurethane or an EVA that are lightweight, you use chemical expansion. This has the disadvantage of having reticulated material that is difficult to recycle. With the physical expansion, in which we use supercritical nitrogen, the material remains thermoplastic, can be recycled, fully recycled in the production waste and post-consumer. Doing calculations, we determined that considering only the material, in the case of polyurethane, the products, meaning the soles, can have a reduction in carbon footprint around 75% due to this technology being capable of producing very lightweight, very high-performing materials. They have a extraordinary capacity of shock absorption and resilience, and they can also be very durable, and also found that they are very high slip resistance. So have a lot of the assets that we need to produce sustainable, durable, lightweight, comfortable products in Europe. With this, I finish, letting my contacts, and prepared for questions that you have. So please be free to contact now or later in the future. And as I said, would very much like to engage and participate and collaborate in the future with all of you. Thank you very much.
Thank you very much, Dr. Ferreira. It was a really interesting presentation and a lot of food for thoughts. At least for me, it's given me quite a few questions and thoughts that I have already. But I think I will open up the floor for other participants in the webinar to start up, perhaps. I don't know if you could stop sharing your screen, Professor Ferreira, so we'll see more of the participants if they are asking questions.
Yes. Okay.
Oh, thank you very much.
Yeah.
Okay, now, is there anybody that would like to open up the questions or remarks to Dr. Ferreira?
Please call me Maria. Yes.
Okay, of course, of course. That is fine, definitely. Okay, but if there's nobody at the moment, but then I'll I could perhaps open up on myself then to get the thoughts and discussions going. I was thinking about challenges on this transformation of both production and use of footwear, shoes, which is the biggest obstacle, or which is the largest challenge to meet when you are working on this kind of issues? Is this the consumers, are the producers, are the materials, or which is the biggest challenges to address, do you think?
Well, one of the challenges is the change that we all are experience, and the consumers are changing, and we need to understand how or what the consumers would like to have. And in this case, we do inquiries, we do researches, we also contract some work to understand the consumer, and what we want is to deploy, to give the consumers the products they like, that they use fully. In this case, the objective is to have, as we understand from the consumers, more eco-friendly products. We decided that eco-friendly would be with lower environment footprint, also durable and recyclable, and this set us challenges for the future in terms of the materials that we are developing. We also understood that the consumers and our clients and the brand want to have resources better used, so going to renewable resources, and this is a big challenge. Sometimes, and when we calculate footprint of products, fossil products, fossil-based products have lower carbon footprint than bio-based products. So this puts us some challenges in terms of communicating the message, but in any way, the decision was to go for renewable products and keep fossil-based products, but guaranteeing their recycling, fully recycling, and circularity. More than recycling is to be really circular. This puts this circularity in terms of footwear puts many challenges, because the complexity of the product is not coming from design wishes. It's coming because a product has a function. So it needs to be durable, it needs to give safety to our shoe, to our foot, needs to be comfortable, and requires different parts. And many of these parts require different materials. At least now they are chemically different materials. And therefore they need to be securely united, normally doing stitches or bonding. And all of these, the diversity of material, diversity of compositions, fixing by these technologies, difficult a lot, makes it hard to cycle, to circulate, to separate, to disassemble the shoes at the end of their life. So this is mainly one of the main challenges, and that we are studying, and we ask you to all be involved in this as consumers or as researchers to contribute to this change in our mindsets, to opt to select for products that can be disassembled, that are having less different materials, in the limit mono material, but I know that this is a topic, but just to see the image of what we are envisaging. Of course, we are also studying and looking abroad. There are some technology already to dismantle, to disassemble shoes. They are not perfect. They need to be researched, they need to be piloted. And what is happening now is when we try to disassemble using this technology, or we are able to feed shoes with the composition that we already know, not in mixing different compositions, or at the end, for example, the rubber that we have is contaminated with polyurethane and so on. And in this case, the quality of the composites that we are able to do is not adequate for footwear. For example, we did some trials in these bioshoe projects in which we separated the soles from the uppers and so on. And with partners, when I say we are always working partnerships, and this was not separated by CTCP, but then we received the materials to do the injection and so on, and detect that even 2% contamination of polyurethane, even though the abrasion, the flexion, the mechanical resistance was not compromised, the look was quite compromised, and the consumer is not ready for this compromise in certain products. So this is a challenge. And the other challenge is a technological challenge. We want to keep the production in Europe, in Portugal, of footwear and all these companies and materials. So we are developing approaches, production methods, and modifying technologies in order to be able to guarantee the production in Portugal at a cost that is reasonable for the consumer and for the brands. And this is some things that we think are fundamental. Of course, we have in our cluster all the kind of companies needed to make the footwear and leather. So meaning the leather companies, the polymeric companies, the sole companies, the insole companies, all the cluster joints, all, and this is a big advantage. But new materials are also needed, namely leathers and this alternative for leathers and polymers, and we are collaborating with European partners and worldwide partners that are also developing materials and some of the ingredients that we need to produce our innovative solutions.
Thank you, Maria. It was the most interesting. As you've described it, there's a lot of challenges to address, and there's a lot of research to be done, both on the consumer side, the production side, the material side, and the introduction of this into the market. But it's most highly wanted based on that we need to transform our use and society into a more circular way of living, and how we use materials, how we use the resources, and so on. But it's very much it's of great interest, and I think that what you have informed us and talked about here, it would fit into many of those areas of thematic groups that we have formulated within the STARS Alliance when it comes to the circular economy, of course, but also into digitalization, digital transformation, into innovation and entrepreneurship, and into sustainable industries, sustainable production, and so on. So I think this is of very good interest, and it should be possible of finding quite a few possible connections and possibilities of collaborations on what you're stating here. So thank you very much. I don't know if there's anybody else that has a comment or a question to Maria. I'm not supposed to be the only one speaking beside Maria, because it's open for participants to join in and give comments and questions as well. Please raise your hand if you have any, or just turn on your microphone and say who you are. I think yes.
Yes, Alexander Project from Krakow University of Technology. I would like firstly thank you, Maria, for very interesting talk. And I'm interested in the type of biopolymers that are currently used in the production of shoe sole or generally footwear. You mentioned about the polyurethane materials, but could you give us more information about other biopolymers that are used in the production of such type of goods? And maybe you also mention about the obstacles to introducing biocomponents that could replace the fossil-based components.
Thank you. Yes, I mentioned bio-TPU. We are also working with bio-rubber, so natural rubber. This is an area that we find very interesting, because there is a lot of raw material available, and in some other cases like BioEva, ethylvinyl we are also working and developing formulations based on BioEva, but sometimes the situation is that there are the biomaterials are still scarce, and it's difficult to buy them with regularity, guaranteeing the future use. So these are the main three types. In the case of bio-rubber, we try, and we are already achieving bio-rubbers, bio-soles with over 70% of bio content. So not only the polymer is bio, but also the additives, the charges that are being used are from bio sources. For example, the silica is coming from rice, and there are other examples. Also, the bio oils are being incorporated. Many times in this case are the performance and the need to really tune the compositions and the reactions that are done. For example, just to give an idea, the first trials that we did with bio-rubber, incorporating some bio oils in concentrations above 70%, we have like some egg so we were not capable of molding any soul or any material. So sometimes the mindset that we have and the production temperatures and process that we are used to apply at lab scale and at production scale, the technologies we need to use the same, but figure out how to use these technologies that are already available to prepare the biomaterials is a challenge, but with some work it is possible. So these are regarding the use. Normally we do aging tests to guarantee that not only the products or the materials fulfill the requirements that we set according to established standards, but also that after use they will be performing. In this case, I think it's very important also to do accelerated aging tests to check the behavior of the materials. Apart from these bio-based materials done with biological resources, we are trying to prepare other biomaterials, for example, based in fungi. This is an area of research. Other approach is using fossil-based materials that are not normally used now in footwear, but are biodegradable. So we are following several approaches to try to deliver to the consumer different possibilities and informed choices. So I hope that I have answered.
Okay,
thank you very much.
Thank you.
Thank you.
Thank you.
And I think that we're running out of time, but I am certain that this discussion and contacts and collaborations will continue. I think there's a lot of possibilities. I know that you're very well introduced and working together with IPB and the researchers there, and hope that it will be extended into other partners and other research facilities and competence within the network, and that we will do things together within the alliance frame based on this, because this is a very important piece of in the jigsaw puzzle about our transforming our way of living and what we are doing, and make it more sustainable in the long run. So thank you very much, Maria, for this, and I hope that we will continue to have contacts, and you will have contacts with us in the alliance and others as well, and try to develop this together. The next seminar coming up in the series will be presented by the Production Technology Center at University West on projects that they have conducted together with the industry on sustainable production, sustainable industry. The title is yet to be confirmed, but it will be advertised on the website and we sent out through the network and in the STARS EU by officers and communication officers. So I'll looking forward to see you on May 15th, the same time as this one, when we hear about those projects and those initiatives on sustainable industry and sustainable production that they will present then. So thank you all for attending, and not least thank you again, Maria, for presenting and sharing this knowledge. It's been a pleasure and really, really interesting to hear. Thank you very, very much.
Thank you so much to you. Thank you all. It was a real pleasure, and hope to see you soon. Thank you.